Okay, let's prove a form of Martingale associated with Sn squared. So let's start with assuming a factor that is a function of an n. So let's assume it's alpha. Just expand the expectation value to this form, because essentially Sn plus 1 is just a sum of all the possible steps with different probabilities. And if we have a square, so this become three terms, right? S squared, 2sx, and x squared. This is a constant. And this is 0 because it's Martingale. At least our Sn is Martingale. Then we left with two terms. This one is pretty much expectation value of x squared, and this is essentially just expectation value of Sn. So we're left with three terms: Sn squared, x squared, and alpha n plus 1. So if we assume if the Sn squared minus alpha n is a Martingale, then we have pretty much for the Sn squared minus alpha n equals Sn minus 1 squared minus alpha n minus 1. Just plug this both sides with this equation. We have n minus 1 alpha n x squared, and we have, because this is a constant, so we can just use this. We can essentially cancel this out to 0, so it's the same, and put this on the right hand side. We're left with alpha alpha n equals alpha n minus 1 equals plus ex squared, and we just keep doing like minus 1, and then we have alpha n minus 1 equals n minus 2 plus x squared, so on and so forth. We add them all together. All of them cancels out here, left with alpha n and alpha 0. And there are in total n times, then we have essentially alpha n equals alpha naught n e expectation of x squared. Thus we have Sn squared minus alpha naught plus n e to the x squared is a Martingale. In a special case, for instance, you have xn equals plus 1 minus 1, half probability. We will essentially have expectation value of x squared equals half 1 squared plus half 1 squared minus 1 squared. Essentially is half plus half equals 1. So we have Sn squared minus n is a Martingale. And this will be useful to calculate random walk. You can use essentially the property of this is a Martingale, and this as a Martingale to solve total step, a probability of termination, and step of termination. So imagine there's like here is 0, distance alpha, distant beta here, we can see if we start from 0, we'll have e to the Sn either goes this way or that way. We'll have, say, reaching here's probability is p alpha. Reaching here probability is 1 minus p alpha. We'll have alpha p alpha plus beta 1 minus equal to 0. Sorry, this is distance, so it's be negative alpha. This is distance, so there's a negative alpha. And at this martingale, we have p alpha squared plus beta 1 minus beta, sorry, 1 minus beta square. Beta square minus alpha, sorry, minus n, where n is the total steps, which is what we want. Based on those two equations, if you solve it, you'll end up having n equals alpha beta and p alpha equals beta alpha plus beta.